Okay, so this video is going to show you how to solve radical equations. So we're going to solve for x, and imagine if you had a square root of x. If I looked at this, I could look at it and say, hey, if I put a 9 in there, the square root of 9 would be 3. And in this case, we're not going to do, it's opposite of what we did when we graphed or solved equations that had a squared in them. If we squared something, we would get plus or minus. But in this case, we know that this has to be a positive number because you can't square a negative number. Or excuse me, you can't square root a negative number. Okay? So in this case, we know it has to be a 9. All right. So let's just think about how would you solve this? The problem is that I want a system or process in order to solve. I don't want to just look at it and say, I think that has to be a 9. So what I'm going to do is I'm going to square both sides. If I square the left-hand side, that would make this square root cancel each other and just make an x all by itself, or basically x to the 1. Which is what I want. I want to solve for x, so I really need x to be by itself. So if I square that side, then I always have to do the same thing to the other side, which would give me 3 squared, which is 9. Okay? So now let's change it up a little bit. What if I had x minus 1 underneath? Can I still square both sides? Absolutely. And if I did that, I would get x minus 1, which would make this all by itself, okay? And 3 squared equals 9. All right, before I finish this off here, look at this. PEMDAS says that you have to do your parentheses and your exponents before you can do your multiplication, division, addition, subtraction, right? The x minus 1 is inside of the radical. I have to get the radical, make it go away first before I can deal with this 1. So if it's all inside here, go ahead, square both sides, and then let's finish off the equation, which will give me x equal 10. Okay, now that we've done a couple of simple equations, let's go ahead and make them a little bit more difficult. So in this case, the 1 is on the outside of the radical, right? So I need to subtract the 1 first. And then I've got the square root of x by itself. Okay, in this case, this is square both sides, x equals 4, and I'm done. All right, what about a cube root? If you had a cube root of something, then if I just cube it, which is use the exponent, then that would make the cubes go away. And I would say, okay, well, 3 cubed, if I did this on both sides, 3 cubed would be 27. And now I can just solve it. If I subtract 7 on the other side, I would get 20, and therefore x equals 10. Okay. So we have x plus 1 this, equals the square root of 7x plus 15. Here's my issue. I have to square the 7x, the square root of 7x plus 15. If you square this side and you go over here to square the other side, which is what you're supposed to do to doing things on both sides of the equal sign, the problem is that I'm going to have to square the whole x plus 1. In other words, I'm going to have to FOIL it, okay? Remember that you have to FOIL. Watch out for your numbers. You might forget something. So write it all out. X plus 1 times x plus 1. And then this other side here ends up being 7x plus 15 because the radical is gone. Now, FOILing it gives me x squared plus 2x plus 1 equals 7x plus 15. I'm going to subtract the 7x on both sides. I'm going to put it right underneath here with my like terms. And I'm going to subtract the negative 15. And that's going to give me x squared minus 5x minus 14 equals 0. Now what do I have to do? Well, I'm going to have to factor it. This is easy factoring, though. I just take the factors of 14, which are 7 and 2, and which one of those will make a negative 5? The negative 7 and a positive 2. Now I'm going to solve x equals 7 and x equals negative 2. Here's my issue. The numbers don't always work. Let's try 7. Let's put 7 back into the equation. This is where the instructions tell us to look for extraneous solutions. If I put 7 in, does 7 work? Yes, 7 plus 1 is 8. And if I do 7 times 7, that's 49, plus 15 gives me 64. So the square root of 64 is 8. Notice that 7 works. Let's try negative 2. Negative 2 plus 1 equals negative 1. Negative 2 times 7 is a negative 14, so that's going to give me a positive 1. This does not work right here. Negative 1 does not equal positive 1. If that is not a true statement, x equal 2 does not work. Sorry, negative 2. Okay, our next example is x to the 2/3 equals 25. Notice that I can write this out a little differently. If you wanted to convert this, you can make this a cube root. That would be the cube root of x squared equals 25. Okay. Notice that if we were to actually do it the same way we've been doing it, you could cube this to get rid of this cube root. So we're going to think about that. How can we do the same thing that we've been doing in the last few examples? Okay. What if I multiplied this exponent, did another exponent over here, which means multiply? What if I multiplied this by 3 over 2, which is the reciprocal? That would give me 6 over 6, which would be 1, which is what I want, x to the 1. Okay, so using the reciprocal and putting it as an exponent right here, which means I multiply these two, gives me 6 over 6, or just x to the 1. But whatever I do on this side, I have to do on this side. Okay, so what is that going to end up being? That means square root, right? The square root of 25. So if I write this out, what's the square root of 25? And then cube it on the outside here. So what does that give me? X equals 5 cubed, because the square root of 25 is 5. So the answer is x equals 125. You can do that with any problem that has a fraction in the exponent. Okay, so let's try it again. This time we have x plus 2 to the 3/4 minus 1 equals 7. Again, this one is extra. I need this whole thing to be by itself. So I'm going to add the 1 over, and I've got to the 3/4 equals 8. Okay. Again, I'm going to use the reciprocal, so I'm going to go 4/3. So whatever I do on this side, I'm going to come over here. So now I've got x plus 2, which because it's by itself now, because these cancel out. And I've got the cube root of 8 to the 4th. And so what's the cube root of 8? Is going to be 2, right? And what's 2 to the 4th? 16. So x equals 14. If you go in and check that, checking for extraneous, you have 14 plus 2 is 16, and the 4th root of 16 is 2, 2 cubed is 8, and 8 minus 1 equals 7. So this is 8 right here, and then this all works. Okay? All right. We're going to check out inequalities really quickly, because if you remember, a graph that is a square root function starts in one place and moves to the right, goes to the right. So the thing is that everything on the left is imaginary, right? Okay, so my problem is that all my inequalities can't go to the left. I have to have somewhere where the domain starts and where it goes to. Okay, so in this one, I have squared both sides. I've got 25. Okay, so x less than or equal to 29. Here's my problem. Yes, it is going to 29. I'm saying that it's going to be less than 29, but it also cannot go past x equal 4. Notice that I have x minus 4, so I kind of know where it's going to stop or start. Okay, so right here, I know that it can't go past 4. For interval notation, this would be 4 comma 29 with brackets on either side. Okay, so we have the square root of x minus 4 is greater than or equal to 5. What if I took this equation and changed it to greater than or equal to? Okay, would I still need this 4? That's the question. If I say greater than 29, I don't care about the 4 anymore. I'm only worried about everything past the 29. I want greater than 29, right? So at that point, I just use x greater than or equal to 29. Notice that in this equation, I only cared about this inside portion. Okay, that's when I had to consider the 4. At this point, I don't have to think about the 4 now. Okay, so just watch out for your inequalities. If it says less than, you're going to want to look at this number here as well. Okay, you're going to want to think about how far this is going. If it says greater than, you're probably going to look at everything that's going this way. Okay? All right, that's it for this video. Please try and look at the homework. Notice that you really just have to think about squaring both sides or doing something on both sides to get rid of that radical. And then if you have questions, let me know. Thanks for watching.